The following question examines the changes in darts players' scores using two statistical tests. In the sport of darts, players take turns throwing darts at the board in order to score points. A player's 3-dart average refers to the mean score achieved when throwing 3 darts. Valia aimed to find out whether amateur darts players in her local area improved over a 12-month period. An increase in their 3-dart average would indicate an improvement. She selected a random sample of 8 darts players and recorded their mean 3-dart average from year 1. She then recorded their mean 3-dart average from year 2. Valia's results were as follows. So it is given two sets of data. Year 1 mean it means players' averages, and Valia calculated the median, quartiles and interquartile range for each year. The results are shown in table 2. Question 8. Determine the values of A, B and C. 3 marks. So you can see we need the median, the quartiles and the interquartile range for year 2. And how to do that? We choose what? Statistics and edit, and we enter this column year 2. It's L2, and also we need one for frequency, and then calc one variable statistics and list. It's L2, frequency it's L3, and we get the result, and you can see that Q1 is 68 is given, the median 70.35, and Q3 is 73.45, and by definition Q3 minus Q1 is the interquartile range. So we get the next, that A is 70.35, B is 73.45, and C is 5.45. The next, B. By comparing the results for both years, summarized in table 2, state one conclusion in context that Valia might be justified in making 1 mark. So you remember, and first of all, we should compare two sets of data using the median and the interquartile range. And you remember how to compare two sets of data. If you use median, you just compare directly. Some median is greater, some is less, and you answer by adding in average. You say in average something is greater than something. And if you compare the interquartile range, the smaller interquartile range, such data is more consistent. More consistent, it means that values are closer to each other, there is less spread. So for this situation, since the median for year 2 mean is greater than the median for year 1 mean, hence in average year 2 mean or year 2 players averages has increased, or just year 2 mean is greater, or players are showing improvement. Notice that according to mark schemes, it's not necessary to write that median for year 2 is greater. You may just write the conclusion. You may start in average and continue. It's not necessary to write that this median is greater than this. Or comparing the interquartile range, and notice that for 1 mark it's enough to compare medians only, or the interquartile ranges only. Or if you compare the interquartile ranges, it becomes, since interquartile range for year 2 mean is less than interquartile range for year 1 mean, hence data for year 2 mean become more consistent, or spread of data has decreased, or players' results become more similar. The next, Valia then decided to analyze the data from table 2 using a one-tailed paired t-test at the 10% significance level to determine whether the players' averages have increased. So one-tailed paired t-test, it's about what? It's about we consider differences, and we consider differences as one set, and it's about the improvement, and see state an assumption about the differences in means that is necessary in order for the test to be valid, 1 mark. Differences in players' averages are approximately normally distributed. It's a required assumption. Or you may say just say normally distributed only, or differences are approximately normally distributed, or the individuals' changes or differences in players' averages are independent. Then DI states the null and alternative hypothesis for the test, 2 marks, and then find the p-value and state the conclusion of the test in context, justifying your answer, 2 and 2 marks. So we should set that let mu d be the mean. Don't get confused. Here mean it's just a name. It's player's average, but mean, it means mean, it's as usual something like sum divided by number, but here it's not directly sum divided by a number. It's not true, but mean, or actually maybe considered like that. Yes, mean, it's like average or mean of differences, and it's important to write not just it's mean, it's mean, and notice that you must write like this: let mu d be the mean of the differences year 2 minus year 1 players' averages. And then the null hypothesis, it becomes just, you may just write mu d 0, and hence the alternative hypothesis, it implies what? No improvement, and since we check for improvement, so the alternative, it becomes mu d to be greater than 0. Or you may write inverse. So h0, it's in average there is no improvement in players' means, and h1, in average there is improvement in players' mean. Then how to provide this test? We choose again what? Statistics, stat, and we should enter differences. Here it's alpha. Definitely it is given, it's already given, but it's clear how to calculate it. It's just this minus this, because we consider year 2 minus year 1, but it's already given, so you just enter, it's L4, and then tests, and we choose t-test, t because standard deviation is not given, or variance is not given. So it's actually always will be true to choose t-test, because for such type of test for difference or test for improvement, So it's t-test, and data mu0 is 0, list it's L4, frequency 1, and there must be greater than, like this, and just calculate, and you can see that p-value is 0.134 to 3 significant figures. So p-value is 0.134, and the conclusion in the context. So since 0.134 is greater than the significance level, here it's 10%. So what we accept H 0, and what does it mean? There is insufficient evidence to suggest that the players' averages have increased. The next, E. State one way Valia could have reduced the chance of your making a type 1 error, 2 marks, and a type 2 error. Let's review what is type 1 and type 2 errors. Type 1 error it's a probability to accept H1 when H0 is true, and type 2 it's accept H0 when H1 is true. So for there is some critical value, and to accept H1 it's when x is greater than critical value, it's just this region, and it's just the significance level, and type 1 error is equal to the significance level. You may just remember this. So to reduce type 1 error, we need just what? To reduce the significance level. So decrease the significance level. It's type 1. And for type 2, since we need accept H0, it will be area to the left, but for it there will be different mean, and hence it becomes this area to the left from this value, but for another mean. And you can see that if you increase significance level, so when you decrease significance level, this value moves to the right and this area decreases, and hence type 1 decreases. But when you increase the significance level, this value moves to the left and this area decreases, hence type 2 error also decreases. Or if you increase the sample size, this become small, squashed, and it becomes more narrower, and hence also this area decreases, so type 2 error also decreases. But notice that it's true only for type 2 error. It's not true, and it's a mistake for type 1 error when you increase sample size. So actually you don't need to know how it arises, so you may just remember the next. The type 2, it's automatically the significance level. So to reduce type 1, you decrease significance level. And how to remember type 2, it's to accept H1, it's area to the left, or something like that. So it's opposite, so you need to increase significance level or increase the sample size. Actually you need just remember this. And the next. Valia was not sure that the assumption made in part C was correct, and hence thought the result obtained from her pair T test may not be valid. Following further research, Valia decided to use the Wilcoxon signed rank test, which does not require the assumption that she made in part C. For this test, the magnitudes of the differences between the year 2 and year 1 means are ranked from 1 to 8 with the ranks of the positive differences P and the ranks of the negative differences N separated in columns. This is partially shown in the following table, which Valia constructs to perform the test. So it is given, and again ranks from 1 to 8, and we consider only magnitudes, and you can see that the smallest magnitude is of rank of 1 and the greatest magnitude is of rank of 8, and we should write separately positive differences and negative differences. It's quite clear, so it's the smallest by magnitude and the rank is 1, and we write here because it's negative, so we write for n. The next by magnitude is this, negative 0.8, it's negative, so we write this rank here, and 1.2 rank is 3, so we write here because it's positive, and you should continue. What is the next by magnitude? The next by magnitude is this, then this, it's negative, then A, it's 7, and you can see it's the greatest, so it has the rank of 8, and it's clear the sum of P is 28 and the sum of N is, you can see it's 8. And actually the next question, F determines the values of A, B, C and D, and the sum of N, 3 marks, it's done. And we read the next. For this test, the Wilcoxon signed rank test statistic is T. This is equal to the smaller value from a choice of the sum of P and the sum of N. The smaller. So the smaller is this, it's 8. So the test statistic T is equal to 8. Then the null hypothesis is that the population's median, let's write that the null hypothesis is that the population's median for 3 dot average is the same in both years. Valia chooses to carry out the test at 5% level of significance from statistical tables. She determines that the critical region, let's write here, critical region is T is less or equal than 5, and you remember if test statistic value is in a critical region, we accept H1. And questions G. I state the alternative hypothesis H1 for this test, 1 mark, since we test for improvement, so we write you just rewrite, but the population's median for 3 dart average is increased from year 1 to year 2. The next, write down the value for the test statistic, T it's 8, and determine the conclusion of the test in context, 2 marks. You can see that since 8 is greater than 5, it's not in a critical region, so we accept H0, and again we write that there is insufficient evidence to suggest that the median of the players' averages have increased. And the last question H, suggest briefly how Valia could assess the reliability of her results for either test, 1 mark. So let's review what is validity and reliability. Validity, or it's about accuracy, does your test actually measure what it is designed to measure? And you should remember that validity, you should remember content, validity, and criteria validity. So content validity does the measure completely measure what it is what was intended to measure. For example, if it's a test on calculus, it must contain differentiation, integration, differential equation, or something like that. And criteria validity, it's about to be predictive, determines how well one variable predicts a certain outcome. It's for example a mock exam. And eventually, if it's question about validity, if you don't know what to answer, you may write just content validity or criteria validity. And reliability, it's about does your test yield consistent result? And you should remember here test retest and parallel forms. So test retest repeat the same process with the same sample at a later time. And parallel forms, it's second set of questions, definitely of similar difficulty and same content. So we can answer for our question. You may write just apply test retest, and it's enough for 1 mark. Test retest. But what does it mean? It means repeat the same process with the same sample at a later time. or she could repeat the test with a different sample for the same year. It will be something like parallel forms. And again, if you don't know what to answer, if a question about reliability, you may write it, apply, test, retest, and that's all. And that's all for this question.